Here is how the reversing valve operates, and there will be a video about reversing valves after this PowerPoint. You can see the reversing valve on the left-hand side, that's cooling mode, and the one on the right is heating mode. And all it does is change the direction whether or not the compressor sends the hot refrigerant vapor to either the outside condensing unit, so it can be in cooling mode, or it sends it directly to the inside coil, what used to be called the evaporator for air conditioning. Now it becomes a condensing unit inside to condense it using the cool air of the home to heat the home. Here's a hot gas defrost valve. When used in conditioned spaces, operates temperature below freezing. So this is what you would use to defrost sometimes the coils in a freezer or other types of coolers that might ice up. Directs hot gas vapor from discharge line to enter the evaporator. Melts frost or ice. Two-way or three-way solenoid valves. Here's a diagram of the hot gas defrost. A little bit easier to see in your book on page 573. Hot gas bypass leaves low load conditions. Small amount of hot gas can be redirected from discharge line into the low side, directly into the evaporator, or into a suction line. System's capacity reduces by the hot gas bypassing condenser and the metering device. Protects compressor from potential damage and prevents short cycling. You can see a pretty good diagram of this on page 575 with the hot gas bypass valve and how it works. And here's that diagram that's on page 575. Hot gas bypass and liquid injection valves. Hot gas bypass valves allows regulated amounts of hot gas vapor to enter the low side. Opens when the low side pressure gets too low, so it doesn't starve the evaporator. Warm suction gases to raise pressure in the suction line. Liquid injector valves allows liquid refrigerant from the liquid line to mix with the hot gas vapor. Uses the discharge line hot gas too hot for the low side. Reduces temperature of the hot gas. Again, this picture is on 575. Crankcase pressure regulator installed between the suction line and the evaporator of the compressor inlet. Protects compressor from excess suction line pressure. As suction line pressure rises, this valve closes. Reduced refrigerant flow, drops in pressure at the compressor inlet. Crankcase pressure regulators prevents crankcase pressure from exceeding preset safety values. Excessively high pressure causes compressor to draw high current, which can cause windings to burn and excess electrical usage. Preventing high pressure prevents compressor overload. Evaporator pressure regulators restricts flow of refrigerant out of the evaporator, prevents evaporator pressure from dropping too low, usually modulating control, variable response to the evaporator pressure. So this is constantly working like a TXV. If the pressure is too low, if it's too high, it maneuvers to make sure it stays within a safe range. EPR use and concepts. EPRs are used in multiple evaporator systems. Lowest temperature evaporators has a check valve at its outlet connecting it to the suction line. High temperature evaporators have EPRs. Evaporator pressure determines evaporator temperature. Evaporators follow Gay-Lussac's laws. Pressure rise equals temperature rise. Pressure drop equals temperature drop. EPR are also called two-temperature valves. This diagram you could see on page 590 and 591. A little bit easier to read on those. Type of EPRs, metering device, opens in a proportion to the evaporator pressure. Snap action, either fully open or fully close. Electronic, sensor measures evaporator temperature. Valve opens in a proportion to evaporator temperature. Stepper motor provides precise valve positioning. Control module accepts measurements and temperature and sends adjustment signals to the EPR. Here's an electric evaporator pressure regulator. Relief valves. Relief valves vents refrigerant when system pressure exceeds a safe limit, usually on high side of the system. Most codes require a relief valve if it is greater than a certain tonnage, if the amount of the refrigerant exceeds the specific minimums, if the internal volume is large enough. Three principal types: fusible plug, spring-loaded relief valve, and rupture disc. There's normally a requirement for inspection of relief valve. You have to inspect every 6 to 12 months, replace every 5 years, inspect for missing and broken seal wires, corrosion, leaks, proper nameplate, stacking springs loader, relief valves, dirt and debris in purge lines. Fusible plugs. Threaded plugs with a metal core. Core melts as much lower temperatures than the outer shell. Allows refrigerant to escape. Avoids dangerous high pressures. When it opens, it releases the entire refrigerant charge. And these are sometimes on very large systems that might hold 20 to 30 pounds of refrigerant. Spring-loaded relief valve vents refrigerant under excess pressure, recloses after the pressure has been lowered, minimizes the amount of refrigerant loss. Rupture disc. Valve body contains a thin metal disc. The disc bursts before the pressure reaches a dangerous level. Usually installed between a system and a spring-loaded relief valve. Pressure measures on the gauge means the disc has burst. Head pressure controls, mainly used on year-round commercial refrigeration in cold weather. Cold temperature prevents refrigeration from reducing head pressure In a system with an outdoor cooled condenser can stop refrigerant flow. Methods of head pressure control are pressure regulating valves, condenser splitting, condenser air louvers, fan speed control and cycling, and electrical heat. Pressure regulating valves operate to flood the condenser with liquid, bypass discharge vapor into the liquid receiver, uses a high heat of discharge vapor to rise high side temperature and high side pressure. Condenser pressure regulator opens on rise of the inlet pressure valve. Receiver pressure regulator opens on rise of differential pressure valve. Low ambient control, combination condenser receiver pressure regulator. Here's a diagram of using a low ambient control. Condenser splitting. Condenser splitting, condenser is divided into two separate spaces, summer condenser and winter condenser. Split condenser valves control refrigerant flow into spaces based on the outside temperature. Here's a diagram. Again, it's in your book. It's a little better, easier to read. Condenser splitting in warm weather.